Today we're going to be looking at section 7.3, double angle identities. You can see the double angle identities on your trig identities sheet, so hopefully you have that in front of you. We're also going to be going through the half angle formulas as well. So first thing that we're going to start off with is the double angle identities and the proof of that. So first thing we have, these are just your identities. So we have sine of 2 alpha is equal to 2 sine alpha cosine alpha. And then cosine of 2 alpha can equal any one of these three things. Now, normally, yes, we would want you guys to memorize these, and we would ask you to memorize all three of those options, because we're going to use them all at different times and different things, depending on what situation we're in. So all three of these you do need to know and use for the cosine of 2 alpha. Sine of 2 alpha, pretty easy to remember. Sine of 2 alpha equals 2 sine alpha cosine alpha. And we do actually use that one quite a bit. So make sure that you know that one. Memorize it as much as you can. So this down here, this is actually the proof. And the proof comes directly from the sum identity. So you can see here that we can rewrite the sine of 2 alpha as sine of alpha plus alpha. And then if you just use that sum identity with this, then you'll come up with this information. And then combining like terms, we end up with 2 sine alpha cosine alpha. That's where that identity comes from. Not a hard one at all to prove. Example 1 says if sine x equals 1/5, and x is in quadrant 1, that's going to be very important to us as well, then find without finding x. So remember, we did some of these quite a while ago at the beginning of this semester. X is in quadrant 1 is going to be very important. And then also remember, when we did these, what we did was we drew our reference triangle. So if we look at a reference triangle, let's label this as x, which is our angle, okay? And so sine would be opposite over hypotenuse, so 1 and 5. And now we can go ahead and use our Pythagorean theorem to find what, we'll label this side a. So we have a squared plus 1 squared equals 25. So go through all of the math of that, and you should get a equals the square root of 24. So when we expand these, this sine of 2x, and use our double angle identities, you're going to notice that we're going to want to know what cosine is. Sometimes you might want to know what sine, but main thing is cosine. So cosine of x is then going to equal the adjacent, which we said was square root of 24, over the hypotenuse. So square root of 24 over 5. We could also write that as 2 root 6 over 5. And then we also, if we did ever have to use sine of x, we know that sine of x is equal to 1/5. They gave us that in the beginning as well. So sine of 2x, if you look at your sheet, that one is one of our easier ones. So sine of 2x is equal to 2 sine of x cosine of x. So I always want whatever variable I'm using to match up. Right? Also notice that we have the sine of 2x here, but when we come over here to the right hand side, that becomes just x. So that is very important to know that we are not using the same angle anymore. Right? That's a double angle identity. It means that we're going from a double angle here to a single angle over here. All right, so 2 is going to stay 2. Well, we know sine of x is equal to 1/5. And then cosine of x is, we just found down here, equal to 2 square root of 6 over 5. So our final answer for that one is equal to 2 times 2 root 6 over 25. pause this just for a second. Okay, we're good. I was looking at the wrong one and thought I had some really strange answer. Confused myself for a minute, but I'm okay. So 4 square root of 6 over 25 is going to be the final answer for sine of 2x using our double angle identity and also the information that they gave us in the beginning. Oh, we forgot to address, good thing I looked back up there, we forgot to address the fact that we need quadrant 1. Not that this changes anything, but just so you guys know that it is something that we need to make sure we're doing. All right, if we want x to be in quadrant 1, then that means that both sine and cosine are going to be positive, which we're fine because we ended up with a positive answer anyway. Just make sure that you're keeping track of that. All right, going on to our next one, we have the cosine of 2x. Now, cosine of 2x has many different options, and I could actually use any of them because I know what cosine and sine are. No, cosine, sine. Well, let's just go with the last one, 1 minus 2 sine squared x. So we have 1 minus 2. Well, what do we know sine is? We know that sine x is 1/5. And then we'll square that. So we have 1 minus 2 over 25. And then let's make common denominator here. So we have 25 over 25 minus 2 over 25, which leaves us with a final answer of 23 over 25. And going on to tangent of 2x, they do have half angle formulas and double angle formulas for tangent. If you're looking at the paper that I gave you, we've whited those out. We haven't asked that you guys memorize them because we know that the tangent of 2x is going to equal the sine of 2x over the cosine of 2x. And we've already done all of this work, so let's just go ahead and use the information that we know and find what tangent is using cosine and sine. So we're going to do sine, which is 4 square root of 6 over 25, what we found in the first part, over 23 over 25. Now we've got our stacked fractions here, so we're going to go ahead and multiply by the reciprocal of the denominator. So turn that over. We've used that now. And our 25s are going to cancel. And we're going to end up with 4 square root of 6 over 23. And that's our final answer for tangent of 2x. I'm going to pause for a second and move on to example 2. Example number 2 is just wanting you to use those formulas that you're given. So use a double angle or half angle formula to simplify the following expressions. So cosine squared of 35 is equal to sine squared of 35. Well, if you look at your sheet, you can see that that is equal to the cosine of 2a. So let's label what we have. This angle, this angle is angle A, as well as this. Those are both A. And then this capital A, if we're looking at the formula, would equal 2 times A. So just using a simple equation, A equals 35, so therefore 2A must equal 70, and therefore A equals 70 degrees, and that's your answer. So that's kind of a nice one. Same thing down here. If you're looking at your formula, you know the formula is cosine squared A minus sine squared A, therefore A must equal 8x. And then on the other side of the equation, that is equal to cosine of 2a. So b equals 2a, and a is 8x. So do a substitution there, and we have b is equal to 16x, and that's your final answer. Example number 3, we have solve 7 sine of 2 alpha plus 6 sine alpha equals 0 for all solutions between 0 and 2 pi. So what I'm going to do is I'm going to try to take this double angle right here and rewrite that. Oops. so that it is no longer a double angle. So I'm going to use my double angle identity. Sine of 2 alpha is equal to 2 sine alpha cosine alpha. So rewrite all of that. So we have 7 times 2 sine alpha cosine alpha plus 6 sine of alpha equals 0. And now we're back to a trig function that we can work with. Let's make that 7 times 2 is going to be 14. And then we've got the 6 in front of there. They both have a sine alpha in common, so I'm going to go ahead and factor out that sine alpha, and now I'm going to simplify. So 14, my sine I factored out, and then cosine of alpha plus 6 sine alpha I already factored, so just plus 6 equals 0. Now I can go ahead and use that zero product property and say that I know either sine of alpha equals 0 or 14 cosine alpha plus 6 equals 0. So domain, we always have to be thinking about domain now. When I'm looking at this domain, I got rid of that double angle. I no longer have to worry about doing any changes for my domain because they're both just in terms of alpha now. So I am just looking for one rotation around the unit circle for both solutions. So that means I'll have 2 solutions for sine and also 2 solutions for cosine. No need for a u substitution or anything like that. So sine theta alpha equals 0. Well, sine of 0, you guys should be getting really good at this, is here and here. So between 0 and 2 pi, it's going to be 0 and pi. So this side, I get alpha equals 0 and pi. We will add on to that over here. On this side, we have cosine of alpha. I'm going to do some algebra here. So subtract 6 from both sides, divide by 14. So cosine alpha equals negative 6 over 14. Oh, I forgot an s in there, didn't I? All right, cosine of alpha equals negative 3 over 7. And now we're going to need to use our calculator for that. So for our arc cosine of negative 3/7, that will be what alpha is equal to. Do that on your calculator. Your first solution should be 2.0137. And then to find our second solution, we're going to do 2 pi, because we're in cosine. 2 pi minus 2.0137. And that should give you 4.2695. So that's our 2 solutions for this side. So putting all of these solutions together, we have 4 possible answers for this equation. Since I only have a minute and a half left to go before this video is going to cut me off, I'm going to go ahead and stop here, and I will start example number 4 on the next video.